Hi everyone, happy Monday. Please make sure to complete the check-in form for attendance. We're going to go ahead today and we're going to finish notes 4.2 and we should be able to start and finish the 4.3 notes. By the end of class today, you should be able to square quadratic equations using the square roots. That's your goal. So we ended last class with just having the word problem left to do. So we have a football player kicks a football 2 feet above the ground with an initial vertical velocity of 75 feet per second. So the function negative 16t squared plus 75t plus 2 represents the height, h, in feet of the football after t seconds. So that should actually say, my apologies, equals h. And t representing seconds. So we want to go ahead and we want to find the height of the football each second after it is kicked. So basically what you want to do is you want to see at 0 seconds, 1, 2, 3, 4, so on and so forth. When you plug in those times, what is your height? So you're literally substituting in, making just regular t table, 0, 1, 2, 3, 4, 5, and just seeing what happens. When you do that, you should get these results here, okay? I just took a screenshot of my table starting at -2, and then I stopped at 6, because if you notice that even at the number 5, you get it to where your height value becomes negative, and obviously we're not looking at negative heights, we're not looking at the possibility of the football somehow going underground when it lands. So I just stopped right there at 6. So using these results from part A, go ahead and estimate at what time does the height of the football reach 50 feet. So really quickly, I'm going to go back to the last slide so you can look at the chart here in case you don't have yours in front of you. And what would be your estimate of the time or times that the football is at 50 feet? Okay, so now let's go ahead and again, you should have gotten 2 times that correlate to this height, because remember, just as when the football gets kicked up into the air, it's going to reach a point of 50 feet at some point, but also after it reaches its max height, it is going to travel back down, so it's going to reach 50 feet at 2 points, one on its trajectory going up this parabolic curve, and then a second time when it's coming back down to the ground. And if we look at this table, you should see that you're probably going to get an estimate for one that's happening between 0 and 1 second, because at 1 second it does reach 61, and then you have another time somewhere between 3 and 4 seconds. And the times are, if we look at this graph carefully, we get it at about 0.765 seconds and 3.92 seconds. So this word problem isn't too difficult because we're really just using the results of the graph that we have. So if we have the equation x squared minus 16 is equal to 0, what are our possible solutions to this equation? Well, the nice thing about this function in this problem is that what we can just go ahead and do is we can isolate the x squared pretty easily by moving over this negative 16. And we're just going to do that by going ahead and we're going to add 16 to both sides. So that gives us x squared is equal to 16. And then in order to eliminate the squared, we're just going to go ahead and take the square root of both sides. And when we do that, that gives us the possibilities of x being plus or minus 4. And if we look here at this function graph, which you could have also done that as well, you notice that it checks out because our parabola does in fact cross the x-axis at 2 points at the positive 4 and the negative 4. Be mindful of the scaling factor in this image. Notice that it shows negative 10 here. So that tells us that we're going by twos. We call this the square root property, what we just did in that last problem. So to solve a quadratic equation in the form x squared is equal to a, we just go ahead and we take the square root of both sides. Just like we did in the last problem when we had x squared was equal to 16, we just simply took the square root of both sides and got both of our solutions. So the square root of x squared is just always going to be equal to plus or minus the square root of a. Algebraically, we say if x squared is equal to a and a is a positive real number, that's really important. Like I said on the notes previously in our last class session, right now we are focused in the realm of the reals. There is going to be a point when we talk about the imaginary, but we're just not quite there yet. But we are just focused on the reals. Okay, so that's really important that we specify that we're talking about real numbers. Then we can say that x is equal to plus or minus the square root of a. And then we'll say again what happens if for some reason our radicand value is negative. So for the first example here, x squared is equal to 121. Simply take the square root of both sides. The square and the square root cancel each other out to just remain with x. Then if we take the square root of 121, we get plus or minus 11. Because remember, this is asking the question of what number multiplied by itself would equal 121. And in this case, maybe it's 11 times 11, so it's positive 11. Or the other case is that maybe it's negative 11 times negative 11. So you have to account for both scenarios. This next problem, x squared is equal to 16. X squared is equal to 16. We want to go ahead and take the square root of both sides, and we are left with plus or minus 4. Notice, for example, 1b. What's going to happen here when we take the square root of both sides of this equation? We have x squared being square rooted is equal to the square root of negative 4. Is this possible? What is the solution? So given that we have an index of 2, remember when there's no index shown, there's an invisible 2 there, and that we have a negative radicand value. This isn't possible in the realm of the reals to create a solution where you're saying these two numbers, this number multiplies by itself twice to create negative 4. So in this case, we say that there is no real solution, emphasizing that word real. X squared equals 0. Go ahead and solve this one. So notice here you just get one solution. X is equal to 0. Go ahead and solve this problem here. So the first thing you should do is if we want to isolate the x squared, that means we need to get rid of this plus 5. So we are going to subtract 5 from both sides because you want to make sure to keep your equation balanced. That equal sign means we need to have both sides of our equations being equal. So that means that if we're going to subtract 5 from the left, we must do the same to the right. And then the next step after that, that gives us x squared is equal to 9. If we go ahead and take the square root of both sides, we are left with x is equal to plus or minus 3. Remember, we could have a negative or a positive value of 3. Go ahead and solve this one. So in solving this one, your first step should be that you want to add 25 to both sides. And that gives you that 4x squared is equal to 25. And then from there, since we want to isolate the x squared, we divide both sides by 4. When we divide both sides by 4, we're left with 6.25. And then in order to isolate the x, because it is squared, the operation that we want to do is we want to square root both sides. When we square root both sides, we're left with x is equal to plus or minus 2.5. Go ahead and solve this problem. So again, the first step, since we want to isolate the x squared before we can touch this term here, we need to get rid of the minus 6. So that means we're going to add 6 to both sides again, using always the opposite operation. When we do that, we are left with negative 2x squared is equal to negative 2. We divide both sides by negative 2, and we're left with x squared is equal to 1. And if we take the square root of both sides, we are left with x is equal to plus or minus 1. You want to paint a square wall in your room. The area of the wall is 100 feet squared. What is the length of the wall? The important factor to this problem is that we see that it says the wall is squared, square shaped. So what that tells us is both the length and the width of this wall are going to be the same length. Keeping in mind area of a square, same thing as saying the base times the height, or the length times the width. So that means since it's a square, we know that these two values are going to be the same. We don't know what that value is yet, but that means whatever this value is, if I call it x, I know that this value here is going to be the same, so I can call this value x as well. So that means if I'm finding the area, I'm just taking the base and multiplying it by the height, or in this case, x times x equals 100 feet squared. X times x is just x squared. So x squared is equal to 100 feet squared. And if we want to isolate that x, we would just go ahead and take the square root of both sides. So if I take the square root of x squared and the square root of 100, I am left with x is equal to plus or minus 10. Now in this case, because we are talking about a wall, it's a real thing, we're only going to be concerned with the positive value of x because we're talking about an actual object and its measurement. So in this case, that means that the length of the wall is 10, and I need to add the units of measurement. That should say 10 feet as the final answer. So 10 feet. So now go ahead and try this one. You want to extend the square wall in your room so that the area of the wall is 200 feet. If that is the case, what would the length of your wall be? So again, still the same concept. The area is base times height, or length times width. And again, it is a square wall, so those two values will be the same. So if I call this length x, this length is also x. And so x times x is equal to 200 feet squared. X times x is x squared. We want to eliminate the square and just be left with the value of x. So I'm going to go ahead and take the square root of both sides. And if I take the square root of x squared, I'm just left with x. And if I take the square root of 200, I am left with approximately 14.14 feet, plus or minus. But again, I'm talking about a wall, and we're looking for the length of this real wall. So we are only concerned with the positive value of 14.14. And again, my apologies, I should have added the units of feet. So that means our wall has a height and a base of 14.14 feet approximately. And that is the end of today's lesson. Again, please make sure that you complete the check-in form as well.